It's an auspicious start. All right, well,
That was
see
for
if we
Brian.
can... Is that for Brian? Oh. Hey,
Fine.
everyone. My name is Fraser Cain, and I am the publisher of Universe Today. And this is your weekly Space Hangout for Friday, January 17th, 2014. So, this week, join me from across the internet. We've got Brian Coberline. Hey, Brian.
Hi.
Question, was Einstein wrong?
Oh, not
We're moving
at all.
on. Casey Dreyer from the Planetary Society.
Hi, Fraser. Good to be here.
Oh, you're scaring me, Casey. Every time
I got good
every
news.
time
Good
you
news.
show up, there
I'm
is
happy
dark,
this time.
dark music, and there's clouds, and I feel sad and depressed. But you promised me this time around we're going to have some good news, so I'm holding you to that. All right?
Or else I'm not invited back. All right, I promise I'll give you something.
No. I like to sort of have you come on to let us know just how hard we have to work to keep the funding happening. So
It's
it's
tough
good
being a buzzkill, but I try.
Yeah. We got Jason Major. Hey, Jason.
Hey, Fraser, how's it going?
It is going well. I'm going to skip over a few people because they're a mystery. We got Dr. Nicole Galucci. How come you don't have your doctor there?
Don't have it here?
No.
I still have. Okay,
I
the
remember.
UVA degrees are like this freaking big.
All right.
But thank you.
Awesome. Okay, so we got a couple of special guests and new people here. So first, I'm going to start with Morgan Renberg.
Yep.
AKA CosmicChatter.org, and Morgan, you're involved with CosmoQuest, right? So you're.
Oh, that's right. I participate in the 365 Days of Astronomy podcast, which is a lot of fun.
Awesome. And you're going to also bring us interesting news about budgets and
That's right.
money.
As interesting as it can be.
And hopefully it's going to be some good news. And we've got a special guest, which is awesome, Mike Simmons from Astronomers Without Borders. Hey, Mike.
Hey, Fraser.
And now you and I met at Sci-Fu down at the Google campus back like May, and we hit it off and had a lot of really interesting conversations. And I had been meaning to have you join us, and finally I was able to make it happen. You're able to
I've been
join
waiting.
us, which is great. And so we wanted to take a few minutes and sort of talk to you about Astronomers Without Borders. Before we do, we've got a little bit more to get out of the way here. So first, we're going to be talking about, of course, the good news and interesting news on the various budgets on NASA and the NSF, which is great. We're going to talk about Rosetta's wake-up call, which last week we had the folks from Rosetta, and now we're going to be we're getting closer. It's time to wake that spaceship up. We're going to talk about normal galaxy in the early universe, massive black holes everywhere. We're going to be testing the shape of the universe, and more information on the budget. So. And we're gonna, if we can, Nancy Atkinson may be joining us with information on this bizarre rock that's been found on Mars. So that one picture it's not there, another picture it's there. What is it? If she doesn't show up, the answer is aliens. So
It's all on you, Nancy.
it's all on you, Nancy. That we're gonna go with aliens, and that's it. Cool. All right, and then the other thing is that if you want to interact with us, you totally can. The best way to do that is using the Q&A app, which is part of the YouTube. So now, no matter where you're watching this, there should be a thing that says Fraser Cain is answering questions live, and then you can click on that, and you'll get this interface where there'll be a bunch of questions, and you can see the video, and you can see the questions, and we're going to try and use that tool to actually let you know which subjects we're dealing with in the show as well. So we'll see whether this works or not. So before we get into that, let's talk with Mike Simmons, and sort of for anyone who doesn't know about Astronomers Without Borders, Mike, what is it?
Well, Astronomers Without Borders is an organization relatively young, but it's gotten very big. The idea is to leverage the idea that astronomy is universal, no pun intended, but and that it's in every country, it's in every culture. We're all doing the same things. I go to the Middle East and other interesting places, and when I look up, I see the same sky as I do back home in California. Of course, with the north-south difference, but it's just part of everything, and we use that to connect people around the world, learn about each other, share resources with those who don't have it, and just about anything we can do in a global community where people are sharing the same passion.
And so, what kinds of projects, have you come together to be able to make happen?
Well, there's a wide variety, and it keeps broadening because astronomy is such a broad subject. We started with things like observing programs. So, say there's a good conjunction or something, and everybody's out doing public star parties and doing outreach, and it turns out everybody's doing it in their own areas. They're doing the same thing. And so, we have people share what they've done and how they do it, and just sort of, it's like having one big star party around the world. But then that spread to other things like sending resources over to and helping people in developing countries, introducing astronomy as sort of a gateway science in countries where they don't have any telescopes and no chem labs or anything in the schools, but they have the lab overhead, and they just need some knowledge to be able to do it. Astro Arts is a big growing program. Space art, performance art, it's everywhere, and it's amazing. The artist community is getting involved in that. That's a whole idea that I wouldn't have imagined, because it's not part of. And our biggest thing is Global Astronomy Month coming up in April, which is a follow-on to 100 Hours of Astronomy from the International Year of Astronomy 2009 that I organized for IAU. And we just had enormous programs and excitement, and it really showed the power of this idea. So we just wanted to follow it up and went kind of nuts and expanded it into dozens of programs for a whole month, and it's out of control, but there's a lot of good stuff.
And so, is that keeping you pretty busy most of the time now?
Well, I haven't slept since 2010. Yeah, for me, it's kept me completely busy. It really has gone completely crazy, and has developed way faster than anything I had ever imagined. I've been involved in a lot of things, never seen anything like it. So, we're I mean, you mentioned budgets. Ours is completely inadequate, like most nonprofits, but we are working on that now, trying to catch up with the demand, because, we're in countries all over the world, and getting by with a little help from our friends and volunteers and a few poorly paid staff.
And so, what are some projects right now that you're working on that maybe people can get involved in? Either people in some of the richer countries to kind of help pitch in, and maybe even people who are more of the developing countries who want to know what kinds of astronomy resources are available to them.
Well, we've sort of dialed back, at this very moment. We have Telescopes Tanzania is always active, and there are occasionally fundraising campaigns for that. That is a group of people that goes over to Tanzania where they have some connections and does training for teachers from all over the country in conjunction with Galileo Teacher Training Program. Take some telescopes, a few resources, and we had, and this is past now, but we've had a campaign to have people donate eclipse viewing glasses for the eclipse across Africa in November, and that was in conjunction with an IAU office in Africa, and many partnerships. So if somebody wanted to right now, I would say we're kind of taking a break at the moment. We're planning for Global Astronomy Month, but there's a lot of stuff that's on the website which is being updated and frankly fixed right now. We have free memberships always. We want people to be supporting members and support what we're doing, and we're planning on boosting that. But people can always join, get the news, and find out what's going on. And there are always things going on the website. And
so what's going to be happening on Global Astronomy Month?
Well, we've got the whole range of programs there. We usually kick it off with a live star party done by Dr. Gianluca Massi in Italy. He does a Messier marathon to start off, and it's not a Google Hangout. It's similar. You see him. There's a chat box. People talk to each other from around the world, and he talks about things as he goes to the different objects. It's like having a 10,000 close personal friends with you in your dome, and he does a number of programs through the month. We'll have observing things we're all observing together, the Lyrid meteor shower, a Mars opposition, and we'll have some special programs for that, some webcasts, everything based online. You can do local events with your club. but the connection is really online, so it's accessible to everybody. We don't. I consider something limited to a continent to be a local event. We don't do that. It's all global.
Right. Yeah. Absolutely. Cool. Okay. Well, so definitely let us know, how we can help, and we can sort of pitch in and get the word out. And with the virtual star party, it's definitely in our wheelhouse as well. So
absolutely.
Help out.
Yeah, we can do a partnership there, and we'll. You got something going that's special, and we can help out with that too.
I actually think I might be trying to do a Messier Marathon this year. I'm going to try and join some friends and actually, instead of trying to broadcast it, just see it all for myself. But we'll see what happens. So one event that I thought maybe you'd be able to speak on as well, which was that Dobson, the creator of the Dobsonian telescope, passed away at age 98.
Yeah.
Yesterday, day before.
A couple days ago.
Yeah. Yeah. We had people tweet their pictures of their Dobsonians at us for Universe Today, and we sort of collected them all together. But did you get a chance to?
Had a feature picture there from the astronomer that runs the Frosty Drew Astronomy, which is right down in Charleston, in my home state of Rhode Island. So it's a very cool little kind of a homegrown observatory that runs off the little coastal town there. Nice dark skies.
Mm-hmm. Yeah, the sort of biggest telescope that I've ever had a chance to work with was a Dobsonian. It was like a 22-inch Dobsonian. It just, was 12 feet long. It was amazing.
The light bucket.
So, yeah, total light bucket. Yeah. Cool. Well, I'm gonna. You can stick around, Mike, if you want. How can people find more information if they want to participate in the things that Astronomers Without Borders is doing? How do they find out more?
AstronomersWithoutBorders.org, or for those who are keyboard challenged, astrowb.org, so ASTROWB.org. As far as Dobson, I think the last interview you did was one that I did. We haven't put the link back up, but I did a live webcast with him 2010, I think. And I've known John since the beginning, like 40 years ago. He lived here in Southern California the last several years, and we'll have that up there as well. And we're also planning something like what you guys did with Universe Today, but we haven't figured it out yet. But it's probably something for Global Astronomy Month, and we'll get the word out on that.
All right. Well, thanks again, Mike, for joining us. Like I said, if you want to stick around and discuss the news, you can. I know you've got a million things. Maybe sleep. That might work.
Well, I can fall asleep on camera, but...
Perfect. All right. Cool. All right. Well, thanks for joining us. Really appreciate it.
Okay. I'll stick around, too.
See you later. All right. Well, let's get on with the actual news. So first, I'm going to... Oh, and Nancy's joined us. Awesome.
Yay.
Nancy,
Hi.
Did you hear my threat? Did you hear what I had threatened? No?
No.
No, I said that if you didn't, that you were going to join us and you were going to talk about the Mars rocket. And if you didn't, then I would say that it was aliens.
Oh.
Well, you could
Good
start a rumor
explanation.
you could start a rumor that Nancy was abducted by aliens who were trying to cover it up. So
cover up the rocket. Yeah, exactly. All right, so let's talk about the.
I'm so sure that that's really Nancy.
They've taken human form.
Let's talk about the budget. So I know this is going to be sort of a 1-2 punch. So I'm going to let Morgan introduce his side of it, and then we'll go from there. So Morgan, you came wanting to talk about budgets. What's going on?
Yeah, well, it's hard to believe I'm even saying that the U.S. has a budget. So that's big news to begin with. But planetary science, astronomy in general, fared pretty well in this budget compared to previous budgets. I'll throw out some numbers to start with, and then we can talk about what it means. NASA gained about 4.5% on its budget for fiscal year 2014. That's about $700 million. And a lot of that went to science. The science office is seeing about 7.5% increase in their budget, and planetary science in particular is seeing about 10%. So that's good news. So that's talking about 130, 140 million additional dollars for planetary science. The NSF also did pretty well. They got about 93, 94% of the money that they wanted, and that goes mostly to fund ground-based observatories. The big one on the horizon, of course, is LSST. And LSST, the Large Synoptic Sky Survey, in fact, was about the only thing that really didn't get a full funding. And it was only funded at about the 50% level for the next year. but the NSF is allowed to transfer funds around to make that happen, which is good for LSST, bad for the smaller projects that are probably going to have their money siphoned off.
And anyone wanting to write a grant for anything.
Right.
Sorry, I keep.
Now, Casey, I know that the Planetary Society came back pretty quick with their response to the levels of funding, and the gist was, that's great, but more is better.
Surprising, I know, right? Well, yeah. So generally, as Morgan said, we're pretty happy with the budget, considering, this is all in context. Last year we had sequestration, which lopped off a good 8 to 10% of a lot of agencies' budgets. That was applied unevenly to planetary science last year, so it took even more than what Congress wanted them to have. So this year, the number that's actually enacted by Congress should be the number that planetary science and NASA will see, which is nice. So $1.345 billion for planetary science, as Morgan said, that's about $130 million more than the White House had requested. We're very happy about this. Of course, we've been arguing our top-line goal is 1.5. That allows us to do a mission to Europa. So what you're seeing is money was dripped towards a Europa mission. They got $80 million to do, nicely described as formulation/pre-formulation activities for a potential mission to Europa. And what that does is basically lets NASA keep the embers warm for this future mission to explore the moon. We made a big push for this in December when they announced that they had these plumes of water vapor coming out of the south pole of this moon. And so it's good, but it could be better. But again, considering we're quite pleased with planetary science and science in general. The big winner in this budget, as you will see and probably have seen recently, is the SLS rocket and also the Orion space capsule. Those two together got about $400 million more than the White House had requested. So those are the two big projects, and you can see that Congress, those are the key things that Congress is really supporting in this budget.
Now Morgan, what was the back and forth? Because I recall that sort of the White House had wanted one budget, and Congress had actually sort of pushed through the bigger budget, right?
Yeah, Congress likes things. So they like rockets, they like astronauts, because those create a lot of jobs. And so that's why we see this big increase in budget for Orion and for the SLS. They want to build things, because build things put people to work in their home states. Often NASA is looking for more a balanced approach, and of course NASA's budget comes through the White House, through the president, and they're often looking to balance human spaceflight with science. And what we see here is we got a lot of human spaceflight, but we did get some science too, and that hasn't always been the case in the past few years. What we also see, though, is that Congress likes telling NASA what to do. So not only do we have Orion and SLS, not only do we have this Europa mission, but they also allocated $65 million directly to be spent on the next Mars rover. And Mars roving, I'd say, is kind of a sore subject in planetary science right now, because we're doing a lot of it at the expense of other things, like going to Europa or exploring other outer solar system planets. And for NASA, or for Congress to basically say you have to spend $65 million on the next Mars rover, this is Mars 2020, is kind of a sore point for some people, because we'd like to have the flexibility to spend that where it's most scientifically interesting.
So Casey, what do you think then? Do you think moving forward that that Europa mission is going to come together? Do you think that some of this pushback is going to increase the budgets more, or do you think this is the best we could hope for, and let's take our win?
There's a lot there. What we're seeing, if nothing else, let's just jump to the big picture. NASA got about $17.6 billion, and that is more than almost anyone expected the case to be. Planetary science got more money. Astrophysics got more money. This, in general, was just great considering. And so let's all just keep in mind, and this is what it's easy to get picky about some of the stuff, and I do too. But fundamentally, we had very good news considering what could have been. NASA did a lot better than a lot of other agencies. Regarding the potential Europa mission, that is so hard to say, because the White House is just basically having none of it. They don't want to commit to a Europa mission. Congress, there's a particularly strong advocate for Europa in Congress. His name is John Culberson. He's from Texas. And when we released our statement, he gave us something to say within that as well. And he is committed to making the U.S. do a flagship mission to Europa by 2022. He, coincidentally, is going to become the top budget chief for the committee that's responsible for NASA's budget starting next year. So that's a great position for Europa advocates. They have a very strong political backer in Congress for this. Whether it still comes to pass, the White House needs to buy into it. So that's the big battle for us, and that's what we're continually talking about and pushing for from us at the Society. We also have, fundamentally, the other thing to keep in mind is that we had tens and tens of thousands of people write this year just through the Planetary Society's website to Congress, and Congress helped us out. We had a great response. This shows us what happens. We're building this new constituency for space science, and we're seeing them really respond to that. And that's a huge victory. Even though we didn't get all the money we wanted, Congress did us a solid and gave us some more money for space missions that we want, and including a variety. They not only did they increase the 2020 rover, which the Society is actually quite happy about, they also increased money for discovery missions, which are these smaller missions to other parts that openly competed to other parts of the solar system. And that's also, they're hearing the whole range, and they want to create this balanced program. So we're seeing the real fruits of a kind of a focused program of political advocacy for space science, which has really never existed this strongly before.
So we've got a couple of questions here, and I think I'm going to throw this one at Nicole first.
I think that's, yeah.
You see this one, it comes from Welsh Nev, which is, do you think that citizen science could replace the lack of funding by governments for cosmology research? So,
well, for cosmology and astronomy in general, I would say no, because unfortunately, you still need money to develop citizen science projects. So what we were saying about the NSF budget is that, yes, we got a little bit of an increase, which is good, because the NSF budget has been fairly flat for the past 13 years at this point. And with astronomy in particular, we're building a lot of new, large, ground-based facilities, and so the facilities budget keeps going up and up and up, and the astronomy budget is flat. The amount of money that is available for grants for smaller projects like citizen science projects is shrinking. And so we won't be able to develop these citizen science projects unless there's money in NSF or NASA or somewhere like that to fund that, to actually fund the development, the scientists and the educators and programmers and everyone who builds that project.
But could you see citizen science funding that stuff entirely? So what you're saying is that we're at the point where the amount of funding left over for citizen science is decreasing.
Right.
Is it possible that crowdfunding, I guess, could come together to fund various cosmology research?
I don't know. I mean,
how bad do you want your space science, right?
Yeah, that's what it comes down to. And this is something we talked about when NASA education budget, which funds citizen science, got, that is constantly in threat of being cut. People brought up crowdfunding as an option, but if you knew how many millions of dollars went into that, crowdfunding $1 million budgets is a little scary.
Yeah.
Can I answer that question,
I would
Fraser?
love to see that happen, but I'm skeptical.
Go ahead, yeah, but I want to move on to the next story, so we'll just do a couple more questions.
Sure.
Oh, and now we've got David Dickinson here. So
I just wanted to quickly add that Congress did add about $20 million more to education at NASA, and they forbade the education and public outreach restructuring, which we had talked about earlier this year.
Yeah.
Though they
I
do
haven't
say,
seen that yet. I love
yes,
you.
they did forbid that. However, they did say NASA just needs to give us more information before we buy into it. So the story isn't over yet, but this year does give a reprieve.
But they already canceled the EPO, the education grant call for the last year. So
this is what happens when you have that
been
division between the White House and Congress. Congress can only react to something that they decide in internal policy, and then they can act on that internal policy regardless of if Congress gives them the money or not. So still got lots of work to do. And then the other question, can you crowdfund these things? My answer, from a person who works at a nonprofit, generally no, particularly not to the level that's the government tends to provide. How you can just tell me how many projects have raised $500 million? And I would say very, very few, particularly for science education. People just aren't willing to do that. This is why you have governments. This is why you have public investment in research and education, because that just doesn't, there's no other way. They fill a hole that no one else does. So that's the important thing to remember. You can't just say crowdfunding and make it happen. this is what governments do, and this is why we need to make sure the governments fill that particular responsibility.
Thanks for joining us, David. If you could put the stories that you want to talk about into the spreadsheet, then I will know what you want to talk about. But I assume you want to talk about the mini-moon.
I can do that.
Yeah.
Yes.
And other things. So that would be great, and that way it'll be as if I'm reading your mind. Okay, well, I'm going to switch topics now. Let's talk about Rosetta and that it's time to wake up.
Wake up, Rosetta. Yeah, I mean, well, it's being called the most important alarm clock in the solar system. After over 2.5 years of roaming about the solar system in sleep mode, in hibernation, Rosetta, Europe's comet investigator, is going to wake up on Monday. We are about 2.5 days away from the wake-up call that the Rosetta spacecraft is going to kind of give itself in order to come out of hibernation, and that's going to occur at, it's going to be 10 o'clock GMT, which is going to be 5 o'clock Eastern time. So it's going to be pretty early in the morning for me, and I think, Nicole, you said there's going to be a hangout going on too, so that's going to be something that happens, pretty early in the morning as well. Well, what's going to happen is it'll give itself a little shake, a little buzz, come out of its 2.5-year-long slumber, so it can heat up its star trackers, and that is going to take about 6 hours for it to kind of warm those instruments up. And once those are working and all nicely toasty, it's going to kind of like give itself a little movement, make sure that its solar panels are facing the sun, and then send a signal to Earth to let us know that everything's okay with it. Now, it's 807 million kilometers away, which is about 500 million miles. That's further than the Jupiter is from the sun. So at that distance, it's going to take about 45 minutes for the signal actually to get to Earth. So we're not going to know if everything's okay with Rosetta until probably about 12:30, 1:30 p.m. Eastern time here in the U.S. Hopefully everything works out great. Rosetta wakes up, all instruments are fine, and then it can start heading out towards its ultimate goal, which is the comet 67P Churyumov-Gerasimenko, which it should rendezvous in August. It'll be the first spacecraft to establish orbit around a comet, and then in November it will land its Philae lander on there, and that's Fraser's favorite part of it because there's going to be a harpoon involved and kind of like shoot down there, make sure it make sure it like clips on. Basically, we have it's a clip-on spacecraft it'll investigate the comet. It's got all sorts of instruments, about a dozen different types of instruments. They're going to see what this comet's made out of, what it feels like, what it sounds like, what it looks like, what it smells like, all of that good stuff. So it's a really, really exciting mission, and we're looking forward to it. But this is the big moment coming up on Monday when it actually wakes up.
Yeah, this is going to be a big piece of our news all year long, becoming more and more interesting as we get closer. But the big step is getting this this wake up call, and then it's going to be approaching the comet. We've never landed a spacecraft on a comet before.
We've never orbited a comet. We've never landed on a comet, and I mean Rosetta's been flying around the solar system since 2004. So it's had almost a decade going around, and I mean it's passed by Jupiter a couple times, it's passed by Earth 3 times, it's gone by 2 asteroids already, but now it's finally going to achieve in 2014 its ultimate mission of investigating this comet. So that's going to be really, really huge later on this year. But ESA has a they kind of put together this little not a citizen science thing, but it's a little outreach where you can send in a video of you and your friends and whoever saying, "Wake up, Rosetta." Wake up, and however you want to do it, hold up a sign, get a group of people together, record a little clip. It could be it could be a Vine clip, but upload it to ESA, and they will be choosing some of their favorite ones. So I think that's still going on up until Monday. So you can check that out on the ESA site.
Yeah, just search for "Wake Up Rosetta," and I'm sure you'll be able to find it.
Mm-hmm.
Awesome. Okay. All
So
right.
good luck, Rosetta.
Wake up, Rosetta. All right.
I got yelled at for saying ESA once. I think it's ESA.
So they literally
Okay,
don't like ESA.
Yeah, because they say you don't say NASA, do you?
Oh, I guess
was like,
you're
Oh,
right.
okay, I guess so. Yeah, so I got.
They actually yelled at you. Oh.
No, they didn't yell
Who
at
yells
me.
at Nicole?
They
Okay,
didn't yell at me.
I'm sorry, Issa.
They corrected me. Kindly corrected me.
All right. So Nicole,
Mm.
which would you like to talk about first? A normal galaxy in the early universe, or the fact that massive black holes are everywhere?
Let's talk about the normal galaxy in the early universe. I heard a little bit of incredulity in your voice for a second there. You're like, why do we care about a normal galaxy? Because it's just normal. But it's pretty cool because it's really hard to see normal galaxies in the early universe because they're faint. So we tend to see bright quasars, galaxies with a lot of star formation, but this is a fairly typical galaxy for about 10.8 billion years ago. I'm not going to read out its name. It's DLA number. It was found in absorption from the neutral hydrogen gas in it actually absorbing the light from a background quasar. In this study, they used the 10-meter Keck telescope to actually image it and resolve it, meaning that they could see detail. And I can probably screen share this really quickly. So it's this blobby little galaxy thing, and it's probably a face-on disk that they're looking at. And they use this this massive 10-meter telescope to image it in infrared and also get the spectroscopy, so also be able to tell the movement and the motions of the gas in the galaxy. So it's pretty cool. They can characterize this galaxy that is a progenitor of Milky Way-like galaxies that we see around today. Star formation rates about 10 times of what our I think it's about 10 times of what our galaxy is. So it's pretty cool to see that off in the distant universe. Someone's ringing.
Someone's ringing. No, that's great. So I mean, the question is like, what did the early universe look like? And I know that with James Webb, this kind of stuff, they're going to be doing a million of these kinds of observations because it's going to be looking so far to the edge of the observable universe. So this is like a taste of the crazy galaxies. I guess the normal galaxies.
The normal galaxies. It's how we came to be in a galaxy like that.
Yeah. Why isn't it a crazy galaxy so early? Okay, now Nancy, you joined us to tell us that in fact, no, this strange rock on Mars is not left by aliens. So what's the story? What's going on?
Well, as Steve Squires said last night, that he's been saying throughout the 10-year mission on Mars that Mars keeps throwing new things at them. Well, in this case, it literally might be true. There was a celebration last night at the Jet Propulsion Laboratory of the 10-year anniversary of the rovers getting on Mars. And if you missed watching it live, we've got it on Universe Today. But it was a great event. It was really nice to see a lot of the people from the mission from over the past 10 years, and a lot of them told the stories of the trials and tribulations and the discoveries. So it was a great event. Anyway, Steve Squires, of course, was there. He's the principal investigator, and he told the story of a recent finding, and this was actually just in the past month, that they were studying this one area in the where the rover is right now in Solander Crater, and they were just taking their normal pictures. And about 12 days later, they came back around and took pictures again in the same location, and they noticed that there was this weird rock sitting there where it hadn't been sitting before. So, that normally has not happened on Mars in the past, where you suddenly see a rock in a place where it wasn't before. And so they've kind of decided either a couple of crazy things happened, either it came out of an ejecta, like there was as Steve Guire said, there's a nearby smoking hole in the ground, and this thing flew over and landed on the area there. Or the other option is that the rover wheel might have kind of dislodged a rock somewhere and kind of squirted it over to a new location. So, and on another idea, I think I saw Fraser on Facebook or something say that maybe it tumbled down from a rock outcrop or something. So, yeah, this picture of this rock has been floating around on social media for the past couple of weeks, but it was nice to hear Steve Squires talk about it last night. So, yeah, it's kind of interesting that to see a rock kind of appear out of nowhere. But so
isn't it climbing a mountain right now? And
yeah.
And things roll downhill from mountains.
Yeah, that's one option. So I mean, yeah, it'll be interesting if they do try to, if they're able to solve the mystery or not. But yeah.
Well, thank you for dispelling this rumor about aliens. I really appreciate that.
Yeah. Well, and one thing he talked about was that it kind of looks like a jelly donut. And the composition of this rock is nothing like they've seen before on Mars. The outside of it is kind of white, and the inside is kind of red, like a jelly donut. And it's got a lot of magnesium and sulfur and just kind of things that they've not seen before on Mars. So it's, in addition to being kind of a mysterious object that appeared out of nowhere, it's also like nothing they've never ever seen before on Mars. So it's pretty intriguing.
So they've done some spectroscopy on it already? I mean, to figure out what it's all about?
Yeah, obviously, yeah. He said that they've got their full instruments on it right now. And the time lapse from when the rock appeared to when the rock wasn't there to when it appeared was about 12 days.
The internet is just going to go berserk on this. Like we batten down the hatches, people. Anyone working for Universe Today, prepare for months of.
This must have just broke. This is the first I'd heard of this. This must have broke today.
Yeah, he talked about it last night at the event.
Very new.
So.
Very new.
Yeah, so everyone's going to forget about ISIN and its.
Cool.
How it's going to cause the apocalypse. And
let it go, Fraser.
This is what we're going to be talking about now.
You're wrong, Fraser. The rock is ISON.
The rock is ISON.
There it is.
That's how we survive.
Finally, a piece of ISON.
Connected.
There's a comet heading toward Mars this October. It's going to pass very near it, so that's going to definitely be on our radar pretty soon. Speaking of comets.
Either that or a Martian laid down its jelly donut as it was.
Yeah, exactly.
Right.
Martian police.
All right. Well, let's move on. So let's talk with who have we not heard? We haven't talked to Brian yet.
Hi.
Brian, before. Okay. So there is a new test for the shape of the universe. What shape is the universe?
It's actually not a new test, but it's a new paper that uses data from the Sloan Digital Sky Survey to apply this test. It's called the Alcock-Pazinski test. Go ahead and do that. Basically what it does is it compares the redshift of objects with their apparent diameter. And so when you look at the correlations between redshift and apparent diameter, you can get an idea of what the distribution of distances are in the galaxy, in the universe. And so it's kind of an interesting paper. It came out in Astrophysical Journal. And what it does is it takes data from Sloan, looks at the correlation between apparent size and redshift, and compares it to 6 different models. Now, the standard model for our universe is sometimes called LCDM. It's lambda cold dark matter, which is a universe with dark energy, dark matter that's expanding. So they looked at different ones. Dark energy, yes or no. Dark matter, yes or no. Static or expanding. And then this interesting one called tired light, which nobody believes in. And what they found was from this test alone, just from the Sloan data, they eliminated 4 of them. So 4 of them were eliminated with 95% certainty, which left only the standard LCDM model or tired light. And before you get all excited about tired light doesn't match the observation of distant galaxies, which should be blurry. It doesn't match the cosmic background. So we've already excluded that from other data. But the nice thing about this test is that it doesn't assume any model about the universe. It just looks at correlations between apparent diameter and redshift. And so looking at that, you've narrowed it down to 2, and then using other data, we can eliminate it all. So we are in a universe that has dark energy, dark matter, and is expanding.
Awesome. I always love how much information gets found in the Sloan Digital Sky Survey. I mean, they find they find information on quasars, and they discover asteroids, and they find comets, and and in this case, they've also figured out that yes, the universe is the one that astronomers tend to agree about. So, so is it does that help with like you say the shape? You mentioned that it was testing the shape of the universe. But we think that it's that it's a flat universe, that it's
it's flat, expanding, dark energy, dark matter. I mean, the interesting thing about this test is a lot of the times when we're looking at cosmological data, we assume one model works and use that to extrapolate the data. So we assume LCDM to, for example, calculate what the distances of galaxies are. Because what we measure is redshift. We don't measure their distances. We measure redshift, and we assume based on the model. But this is one of those things where we already have the data that says how the universe is, but this doesn't depend upon the model. So you can say, okay, let's just throw it out there, see if it agrees. It's one more observation and one more set of observations that confirms, yes, we do understand the universe. Our understanding of the universe is valid, and here's another thing that kind of throws onto the pile. Yep, yet again, LCDM works.
Yeah, it's good. I mean, it's great to have those kinds of models where you've got lots and lots of separate lines of evidence. You can bring them all together, and you can look at it from every perspective, and it just keeps getting stronger and stronger. So let's move on.
So the universe isn't shaped like a potato chip? They always like that.
It's shaped like a jelly donut, isn't it?
A donut, that's what Homer says, yeah.
Yeah.
The jelly
David
donuts in
Dickinson.
Mars, jelly donuts in the universe, as below, so above. Oh my goodness.
Yeah. Donuts all the way
I
down.
think you just broke my brain.
David Dickinson, first I would let we're going to talk about the mini moon, but before we do, I want to congratulate you on coming up with a name and us making it stick. It
seems to have.
It has absolutely stuck now. So David said, I want to come up with a name for, what do you call the opposite of a supermoon? Because this just didn't have a name. And he proposed a bunch of names, and I think in the Weekly Space Hangout, we agreed that we liked the mini moon best.
Yeah.
And then we've been pushing it and memeing it. And
what's wild is we have some other SEO to contend with, because I found out that mini moon also means a miniature honeymoon, a small honeymoon.
And it's also a Sailor Moon character.
It's among a Japanese anime character too.
Yeah.
So we're kind of trying to take that meme away from some other established memes already. But it's good to kind of combat supermoon, because people have a love-hate relationship with that, because it was an astrologer that actually coined that phrase back in the 80s. So it's kind of stuck with us on the internet. I always prefer Proxygean moon for supermoon, but
but I will know that it really has seriously happened when we see it on Urban Dictionary and we see it on Wikipedia.
Yeah, I saw it this week around a few news sites. I saw it on space.com. A few other people were starting to use it now, so it's starting to gain traction.
Perfect.
And this week's mini moon was actually, I wouldn't call it super, maybe an extreme mini moon, because this one was nearly as close to apogee. It was within 2 hours and 58 minutes of apogee. It was pretty close, and I looked back through on Formulab's calculator, and the last time we had one closer in time for apogee in full moon was 1994, and actually there was an eclipse during that one, so that's another rabbit hole to figure out how rare a mini moon with an eclipse is. And the next one isn't until May 13th, 2052. That's an hour and 41 minutes apart. I get in a whole discussion with me and a few other friends. We like to look through this kind of stuff for fun. And this one was nearly as far away as it can be at 406,527 kilometers, which is about less than 500 kilometers from the maximum apogee. Every apogee is not the same. Neither is every perigee. The moon gets slightly torqued by the sun, mostly, and other planets, but mostly by the sun. So apogee and perigee, the motion of the moon is very complex. The more you look into it, and the further you look back in time, the less accurate these desktop planetarium programs get. So it's really tough to say when the last time this one was surpassed with any kind of accuracy.
So that was the closest, but that was the closest mini moon that we're going to see for like around 40 years. The
most distant, when I say closest, I'm always saying closest apogee in time to full moon, because full moon is just an instant. You go from waxing gibbous to full moon and then waning gibbous, but that instant that the moon is new or full, that's an infinitely small instant in time. That's the moon is really, it's never quite 100%, even when it's in eclipse. So actually, when it's closest it could be, it would be an eclipse. So.
And I noticed yesterday that the water on the ocean was unusually calm. Like there were no waves at all. It was just, it was like glass.
And I also have to combat the idea that when we say the smallest moon of the year, the moon is not shrinking or growing. This is apparent visual size. Usually we like to say the moon is about half a degree or 30 arc minutes across. That's visual size of the moon. When the moon is new, or when the moon is at apogee, it's not quite, we lose about maybe 0.7 of an arc minute of angular size, 1 arc minute being a 60th of a degree. So the moon actually varies over the span of 29.3 to 34.1 arc seconds, about 5 arc minutes, excuse me, not arc seconds. That's a whole different size measurement.
But David, awesome. I thought the moon was hollow anyway, so it just expands and shrinks. However,
it just expands and shrinks, or it's made of green cheese, or
it's the size of the sun. I've seen
an interesting thing to do. Of course, I know when the mini moon is and the perigee moon because I'm looking at these tables and things like that. Is to see if you can go out and look at a succession of 12 full moons and see if you can tell which one is the closest full moon of the year and which one is the furthest, just visually. That's an interesting little year-long experiment, and I think a trained observer could spot that little 5 arc minute difference. It is discernible. It's
pretty surprising when you see the two side by side. There is a big size difference between the moon when it's at apogee and when it's at perigee.
Yeah.
Okay, well let's move on. So Nicole, you've got a second story about massive black holes being everywhere.
I do. This one's also from last week's AAS meeting. The American Astronomical Society met in this tiny little resort town in Maryland. It's very odd. But there was a story that came out from a former fellow grad student of mine at University of Virginia who's now working for the National Radio Astronomy Observatory, Amy Rines. And she made a serendipitous discovery a couple years ago in that she found a very massive black hole in the center of a dwarf galaxy. Now, we are pretty sure that everywhere we look at a large galaxy with a bulge, there's a supermassive black hole in the center. Everywhere we look. But the dwarf galaxies didn't have these black holes. It was thought no bulge, no central black hole. Well, she stumbled upon this one particular supermassive black hole. She's calling them massive black holes, not supermassive, because they're only 10 to 100,000 times the mass of the sun, as opposed to millions and billions of times the mass of the sun. So they went ahead and did a survey. They went through archived data. I believe it was archived Sloan data of 25,000 dwarf galaxies, and she and her collaborators found over 100 of these accreting massive black holes. So 100 out of 25,000 doesn't sound like that much when you look at it from the start, but then you realize, well, that's 100 that they found, and they're only finding the ones that are active. Well, we know from normal-sized galaxies, dwarf galaxies, large-sized galaxies, only about 10% are active at any given time. So this might be just the tip of the iceberg of these massive black holes that are in the centers of dwarf galaxies. And I actually went out of my way to point out that calling this a paradigm shift is actually not too far off. Usually that phrase gets thrown around a lot. But to think that there are massive black holes in the centers of all these dwarf galaxies as well is a pretty big shift from our previous thinking.
Brian, what do you think as an astronomer person? Is that it? Supermassive black holes at the heart of all galaxies?
You mean out of like Milky Way type galaxies? Yeah.
Well, I mean, the dwarf galaxies too. Anything, any collection of stars.
It's
monster black hole in the middle.
Interesting result. I mean, this is still early, but yeah, I mean, the fact that you're finding this many black holes in dwarf galaxies is big, and it's surprising. Mm-hmm. You know, our dynamics of dwarf galaxies, we haven't thought that they would be containing a black hole, and this evidence at least looks like a good chunk of them, if not all of them, do have at least massive black holes, whatever you want to call them, but big black holes.
On that.
and that's. I think Nicole's right. It is kind of a paradigm shift.
Do you think that would provide any evidence either way for whether it's the black holes or their galaxies came first?
It could. I mean, the fact that they're there, I think, would lean more credence to the idea that black holes come first.
So what's next, Nicole? Then what do you think? What kind of research is going to have to happen to dig further into this?
Well, they're studying these black holes in particular because of the question you just asked, in that we don't know what the progenitors of, I keep using the word progenitor today, the progenitors of supermassive black holes, we don't know exactly what they are or how they were formed because it's very, very distant and very, very far away. But these black holes are examples from at least some of the models. They were about the same size as some of the models for what progenitor black holes look like. So I think by studying these properties, they may be able to get a handle on that, which came first question, and maybe see what they were like in the early universe. So now that they found Sloan data, they're probably going to be applying for telescope time to individually study these actively accreting black holes.
Yeah.
Awesome. And then next we find primordial black holes.
That would be cool, but gosh, they're so far away.
Okay. All right, so let's move on. So I think this is the last story of the day, and this is just going to be, I hope, a quick video here. But David, you've got a video of Jupiter and the moons from our good friend Michael Phillips.
Yeah, Michael Phillips did that. Yeah, that was kind of cool, and I was glad I could feature it because it had a very 3D look to it. And it's Jupiter's viewing season right now with it just passing opposition a few weeks ago. So I was pretty amazed at the capture he got. And it's just amazing what amateurs are doing, things that professionals weren't doing 20 years ago as far as imaging. It's pretty incredible.
Let me see if I can take up this video because it's pretty spiffy. Although, yeah, here it is. Yeah, and I know that Michael wants to top it, so his goal here is, I think I got the video here. Let me just see if I can bring this up.
I thought it was amazing. He has Io passing in behind Jupiter into its shadow, and he caught Ganymede passing in front. And if you look at Ganymede really close, what amazes me is you can see some detail on Ganymede. He actually caught a little bit of detail,
here we go,
which you generally don't need to see at the eyepiece. And you can see how the moons are casting their shadow back, almost straight back right now. But it's like, that's pretty incredible. And he got the great red spot in front too, which is actually becoming more active right now, just a little bit. So
I think what's really neat and important about this work, right? It's like Michael has produced just astonishing still images of Jupiter at this level of quality, and he's now cranking up his methodology. So not only is he going to take a single frame of Jupiter, he's actually now stitching these together into time-lapse animations. And obviously the goal is to get one full rotation of Jupiter. And
if I remember off the top of my head correctly, he's shooting this with a 14-inch telescope. He's got a Flea 3 webcam that's designed for astrophotography. He's doing 120 frame series, and he's stacking them together. Then he has to send it to a program that deconvolutes the rotation of Jupiter at the same time. So it's pretty amazing.
Yes. All hail Mike Phillips. Now, you can see Mike's work. This is still going on in my ear here. You could see Mike's work on the Virtual Star Party, and so he often joins us, and he's our main planetary guy, although he's now started to go very deep sky, but he has brought us Pluto, Uranus, Neptune, Saturn, Jupiter, Mars in various hangouts. So, yeah. Okay, great. Well, I think we're time to wrap this up. So before we do, though, I want to give everyone a chance to shamelessly self-promote themselves so that people can find out more. I'm going to start with Brian Coberline. Brian, where do we find out more?
You can find me on Google+, where I post daily. You can also find me on my website, which is briancoberline.com, and Twitter and everywhere else. But Google's where I mainly am.
Yeah, and you have occasionally written some articles for Universe Today, including... the recent, wildly popular, was Einstein wrong? Why Einstein will never be wrong.
Never be wrong.
I enjoyed that
article, by the way, Brian. Good job on that.
Thank you.
Way to throw yourself to the sharks.
You know what was funny is they argued the same thing in the comment thread. Like, did you guys even read the article?
Yeah, absolutely.
Yep.
I think. Well, it was great. You mentioned that. I think you mentioned that last week on the Weekly Space Hangout. That was where I think you're explaining this philosophy, and then it turned into an article, which I think was great.
Turned into a post. Yep.
Yeah, which I thought was great. So, Casey, where do we find out more? He's muted. Uh-oh, you're muted, Casey. Still muted. Oh, you can come back. We'll go with David next. David, where do we find out?
Let's see. I was active this week on Listosaur, Universe Today, my own site, AstroGuys with a Z. I tweet at AstroGuys with a Z, and I have a new sci-fi self-published story on Amazon called Helium Party. It's about space clowns. Great story.
Jason Major. Where do we find more Jason Major?
lightsinthedark.com. I am on Universe Today and Discovery Space News, and I am very active on Twitter at JP Major. Next week, if you want a hands-on almost tour of Goddard Space Flight Center, I'm going to be there looking at some of the pieces from the James Webb Telescope coming in and their clean room and some bits and pieces during the NASA social. So I'll be putting a lot of that stuff up on Twitter and on my website, lightsinthedark.com.
All right, Casey, let's try that again. Nope. I think he's... Oh, well.
He's talking very, very, very quietly.
All right, well, you can find more Casey at the Planetary Society, planetarysociety.org. I hope I got that right. All right, I'm going to move on to Morgan. So, Morgan, I see your URL, cosmicchatter.org.
Yep, the website is cosmicchatter.org. We're cosmic_chatter on Twitter. We'd love to hear from you.
Fantastic. Nancy Atkinson, where do we find out more?
Universe Today, pretty much every day, and I'm Nancy_A on Twitter, and I'm at Facebook sometimes. Google Plus sometimes.
Nicole Gallucci.
Hi, I'm Noisy Astronomer. I work over at CosmoQuest. Come check out the forum, the CosmoQuest, the home of the Bad Astronomy Universe Today forum, because we all went.
Yep.
We are actually doing a giveaway. Pamela and I have so much space swag we have collected over the years that we found in the move that if you are a senior or established member on the forum or have marked 100 or 1,000 images on CosmoQuest, you can win a fabulous prize. So go check out cosmoquest.org/forum. Also get involved in some of the discussions going on there. I've been getting more active on the forum finally, and it's pretty fun. So come join us.
And Mike, special guest Mike, where do we find out more?
Well, if you can type a URL as long as astronomerswithoutborders.org and get borders right, because some people think it's B-O-A-R-D. It's B-O-R-D-E-R-S. We don't take in letters.
Astronomers without house guests.
Right, yeah. And so that's the website where everything is happening. You can sign up for our newsletter. We're also active on Facebook. Twitter is AWB_ORG. And this coming Thursday, we will have our monthly hangout as well, where we'll talk about some recent things that have gone on in Africa. I just got back from North Africa, and we had an eclipse support thing going on. So we're going to have guests from Tunisia, Nigeria, and Libya talking about things happening there as well, and our AstroArt thing. So if you go to one of those places and learn about a hangout, you can join us there.
Fantastic. Great, and once again, I am Fraser Cain. I am the publisher of Universe Today. You can see me on Google Plus mostly, on YouTube. We're posting a bunch. We just recorded 11 new videos yesterday with my brand new Canon 5D Mark II camera, so they look great. Ooh. Yeah, it was really nice. It was a real pleasure to use this camera. And I'm also on Twitter. I've been drag kicking and screaming into Twitter, so you can find me at fcain on Twitter. Cool. Well, thanks everyone for watching, and the next thing is probably going to be the virtual star party on Sunday night. So hopefully we'll see you all there, and if not, we'll see you all next week. So thanks for watching.
Wake up, Rosetta!
Wake up, Rosetta!
That's right.
Maybe we should do that. We should record that. Should we all tell Rosetta to wake up, and then all right, everyone. On the count of 3, okay? 3, 2, 1, and we'll all say wake up, Rosetta, okay? All right. 3, 2, 1.
Wake up,
in the show as well. So we'll see whether this works or not. So before we get into that, well, let's talk with Mike Simmons, and sort of for anyone who doesn't know about Astronomers Without Borders, Mike, what is it?
Well, Astronomers Without Borders is an organization relatively young, but it's gotten very big. The idea is to leverage the idea that astronomy is universal. No pun intended, but and that it's in every country, it's in every culture. We're all doing the same things. I go to the Middle East and other interesting places, and when I look up, I see the same sky as I do back home in California. Of course, with the north-south difference, but you know, it's just part of everything, and we use that to connect people around the world, learn about each other, share resources with those who don't have it, and just about anything we can do in a global community where people are sharing the same passion.
And so what kinds of projects, have you come together to be able to make happen?
Well, there's a wide variety, and it keeps broadening because astronomy is such a broad subject. we started with things like observing programs. So say there's a good conjunction or something and everybody's out doing public star parties and doing outreach, and it turns out everybody's doing it in their own areas. They're doing the same thing. And so, you know...
People, because they're a mystery. We got Dr. Nicole Galucci. How come you don't have your doctor there?
Don't have it here?
No.
I still have... Okay,
I
the
remember.
UVA degrees are like this freaking big.
All right.
But thank you.
Awesome. Okay, so we got a couple of special guests and new people here. So first, I'm going to start with Morgan Renberg.
Yep.
AKA CosmicChatter.org, and Morgan, you're involved with CosmoQuest, right? So you're.
Oh, that's right. I participate in the 365 Days of Astronomy podcast, which is a lot of fun.
Awesome. And you're going to also bring us interesting news about budgets and
that's right.
Money.
As interesting as it can be.
And hopefully it's going to be some good news. And we've got a special guest, which is awesome, Mike Simmons from Astronomers Without Borders. Hey, Mike.
Hey, Fraser.
And now you and I met at Sci-Fu down at the Google campus back like May, and we hit it off and had a lot of really interesting conversations. And I had been meaning to have you join us, and finally I was able to make it happen. You're able to
I've been waiting.
Which is great. And so we wanted to take a few minutes and sort of talk to you about Astronomers Without Borders. Before we do, we've got a little bit more.
We have people share what they've done and how they do it, and just sort of, it's like having one big star party around the world. But then that spread to other things like sending resources over to and helping people in developing countries, introducing astronomy as sort of a gateway science in countries where they don't have any telescopes and no chem labs or anything in the schools, but they have the lab overhead and they just need some knowledge to be able to do it. Astro Arts is a big growing program. Space art, performance art, it's everywhere and it's amazing. The artist community is getting involved in that. And that's a whole idea that I wouldn't have imagined because it's not part of. And our biggest thing is Global Astronomy Month coming up in April, which is a follow-on to 100 Hours of Astronomy from the International Year of Astronomy 2009 that I organized for IAU. And we just had enormous programs and excitement, and it really showed the power of this idea. So we just wanted to follow it up and went kind of nuts and expanded it into dozens of programs for a whole month, and it's out of control, but there's a lot of good stuff.
And so, like, is that keeping you pretty busy most of the time now?
Well, I haven't slept since 2010.
It's an auspicious start. All right, well,
that was for Brian.
Is that for Brian? Hey, everyone. My name is Fraser Cain, and I am the publisher of Universe Today. And this is your weekly Space Hangout for Friday, January 17th, 2014. So, this week, join me from across the internet. We've got Brian Coberline. Hey, Brian.
Hi.
Question, was Einstein wrong?
Oh, not
We're moving on. Casey Dreyer from the Planetary Society.
Hi, Fraser. Good to be here.
Oh, you're scaring me, Casey. Every time
I got good news.
Every time you show up,
I'm happy this time.
Dark music, and there's clouds, and I feel sad and depressed. But you promised me this time around we're going to have some good news, so I'm holding you to that. All right?
Or else I'm not invited back. All right, I promise I'll give you something.
No. I like to sort of have you come on to let us know just how how hard we have to work to keep the funding happening. So
it's tough being a buzzkill, but I try.
Yeah. We got Jason Major. Hey, Jason.
Hey, Fraser. How's it going?
It is going well. I'm going to skip over a few to get out of the way here. So first, we're going to be talking about, of course, the good news and interesting news on the various budgets on NASA and the NSF, which is great. We're going to talk about Rosetta's wake-up call, which last week we had the folks from Rosetta, and now we're going to be we're getting closer. It's time to wake that spaceship up. We're going to talk about normal galaxy in the early universe, massive black holes everywhere. We're going to be testing the shape of the universe, and more information on the budget. So, And we're gonna, if we can, Nancy Atkinson may be joining us with information on this bizarre rock that's been found on Mars. So that one picture it's not there, another picture it's there. What is it? If she doesn't show up, the answer is aliens. So
it's all on you, Nancy.
It's all on you, Nancy. That we're gonna go with aliens, and that's it. Cool. All right. And then the other thing is that if you want to interact with us, you totally can. The best way to do that is using the Q&A app, which is part of the YouTube. So now, no matter where you're watching this, there should be a thing that says Fraser Cain is answering questions live, and then you can click on that, and you'll get this interface where there'll be a bunch of questions, and you can see the video, and you can see the questions, and we're going to try and use that tool to actually let you know which subjects we're dealing with in the